Good evening, Martin. How are you?
Good morning, Regina. How are you?
I'm fine. Are you able to view my screen?
Yes, I can see. Yes.
Okay. So yesterday I shared two vagrant files with you.
Yeah, you sent it in email. Yeah.
Yeah, to your email. So we actually only in Vagrant we have left two commands. One, how to modify a Vagrant file and how to create a this VM, multiple VMs.
Okay. Right.
Okay, so I'll just show you. So this Vagrant file is visible.
Yes, it's visible.
Okay. So when we configured, so the word which we use in Vagrant file to configure is do.
Mm-hmm.
Okay. So whenever we start configuring, when we are yeah, so each do has its end. If each do is not having its end, then it will give an error. Suppose you see
Okay.
this is vagrant configure do config. Okay, so this is the beginning of our parameter. So here
Mm-hmm.
the end is here. Okay,
Okay. Uh-huh.
and when we are having now do means here we are configuring the VM. Okay, so
Mm-hmm.
we are giving, we are defining the VM. We are calling it as web server. If
Mm-hmm.
we don't define here, if we don't write config.vm.define here, then it will take as default.
Okay.
In last session I have shown you now without giving any name here, so it is giving default. But if we give here, we define here the VM web server. So now when we do vagrant up, it will take a name as web server, and then and now one thing is to take care here is web server, what the name we are giving should be identical in defining the VM, defining the host name, and defining the virtual box name. So if you see here, I have made a mistake in this vagrant file. You have to make change that only to show you. Web server, here W is small. So we have to make it as web.
Okay.
Okay, so it will be a same name. There will maybe not any change in the name. Okay, so now host name is web server. Now here we define what type of box, whether Ubuntu, HashiCorp, CentOS 7, whatever box we want to VM virtual box, the VM name provider is here. Okay, so we give the name here. Now we have to give a network also, because when it creating a VM, it is forwarding port as well as forwarding the port 80 to 80, and here we give the IP address.
Okay.
Okay, now next is, so we are doing this do. Now next again we come here do. Okay,
Mm-hmm.
do is here. Do means now this do is having end here. So what we are doing, we are giving the property of provider, virtual box provider. Okay, so VB name is web server, and the memory we are saying 2048, or we can give it 1024, whatever the memory we require. It depends on the requirement. Suppose you are using Vagrant, you are creating a VM, the user has given you, user will give you all the parameters, that what memory he needs, what provider of a what provider of VM virtual box he needs, what type of VM it is, whether it is Ubuntu, HashiCorp, or what type of any other available virtual box VMs.
Okay. So the users will tell us.
The users will give us, and on that basis we make the changes in the vagrant file, and then
Okay.
when we do vagrant up, then it create a VM there.
Okay.
Okay,
Mm-hmm.
now it is config VM provision. Now here what we are doing, in this we are installing an Apache, whatever the software type, if Tomcat server or any web server a user wants. So here we have taken as an Apache too. Okay, and then
Okay.
now to see whether it is okay or not, we have echoed this part. So now if you see here shell, okay, now shell. So at present we have not studied chef and all those. So what we are just using a simple shell command in this initial vagrant file. When we do chef puppet or what, so we will create a vagrant file using VM provisioning using Ansible, chef, or puppet. That what will be the command that we will give here. So config VM.provision. This will provision of VM.
Okay.
Whatever the requirement is there. What type of VM is there? What provision, what environment you are provisioning, what software you want to install on that VM.
Okay.
Okay, so in this way, app get update. So whenever we install, we check for the updated version.
Okay.
Okay, so app get update and then app get install. We are taking here as from the root directory. So I missed one point, syncing the folder. Okay. So here sync folder means this is on a host machine. The first parameter, the first argument is for the host machine, and the second argument is for the
Virtual box.
virtual box. Okay. So now we will see here this how this vagrant file. Okay, I'm just closing it. I say vagrant up. I haven't used here vagrant init because if I use vagrant init, then this file will be changed. So we have to update it out. That's why I've just started with vagrant up. So if you see here, it's giving bringing machine web server.
Yeah.
So we have not defined it, then it will give a default. It take it as a default.
Okay.
Now here, if you see, it is forwarding ports 80 guest to 8080 host and 22 guest to 222. That is the port is 222 of host and this.
Okay.
Today I will also show you how we can use putty for using creating a connecting vagrant with using putty. Now at present we are using an this shell. We are using this command line. So how using putty we can do it. Connect to the VM script.
Okay.
Okay, and here one more thing in your file. If you, I have given GUI as true. The file which I have shared with you, I have given GUI as a true. If GUI in a file GUI as a true, so what it happens when it was booting a VM, it will open a virtual box, Oracle virtual box, and then it will show, because here it is not giving me the all the commands to install Apache 2 because we have to command app get update. Now when we have said app get update, we find that Apache updated version is on your, because we have created when we have destroyed the VM, the folders are not destroyed, it is only shut down the VM and it will remove from the virtual box, but it is there on your host.
Okay.
Okay, so if you see here, this is a folder vagrant dot vagrant. Okay, so here you have machine, web server, virtual box. So it has all the details, because when it was destroying, it is not destroying it from your this.
Okay.
What I will do again to show you this vagrant hall, I will show you one thing. Okay, if I say vagrant SSH, using vagrant SSH, I will go to this virtual machine. So here, if you see these two commands, mounting a share folder, D DevOps vagrant, and on a VM, it is going for this var www.html.
Okay.
Okay, so now we have come to this vagrant web server. If I say here ls minus la, okay, so it has given that total 28 is there on the server. You see bash logout dash cache profile ssh.
Okay.
And why not index handle? And now if I go to cd slash var www.html, which is on. Now, if I say ls here, so this index.html is there.
Okay.
Now, in this vagrant, so what I will do, I have come to the vagrant. If I say vagrant, 1 minute, okay. So this way it has created. Now I will show you one thing also, because it was a. Now I will say vagrant halt. So now it will stop the VM. Vagrant halt is to stop the VM. Shutting down the vagrant. So now it will destroy the VM. The VM. First it has shut down, and now it will destroy. It will always ask if I have written a command as vagrant destroy hyphen f. Okay, so it will not ask for me with this yes or no confirmation. It will not ask for the confirmation after confirmation. Now you say, you see it has been destroyed, but you will find here, if I say vagrant, this vagrant dot and the machine's default and web server, all the details folders are. So this dot vagrant virtual machine was there. Now, so that's why when I was doing it is installed. If I will go to this and I will search for Apache, if I say localhost 8080, from here I'm removing this vagrant folder completely. Okay. Now if I will vagrant up, now it will create again and then it will install. Meanwhile, you can also try this on your. You have to. What you have to do, you have created this folder where you can put this vagrant file.
Okay.
So vagrant file, I have sent one vagrant file and one vagrant file 1. So vagrant file 1 is for multiple VMs and vagrant file is for using this Apache.
Okay.
So just put that and just here it has shown some error. Are you able to do?
I'm sorry?
Yeah, are you able to copy the file and vagrant up?
Oh, no, I've not copied it yet. I'll download tomorrow morning and then practice.
Okay. So I'm opening another editor in which
Okay.
I will show you how to create a multiple list. So in case whenever you feel, if you feel any issue, then just let me know. So what
Okay.
I will just. So I have created this one another Vagrant file, okay,
Mm-hmm.
and another folder. So if I open Edit with Notepad, so I was thinking you are doing that's why I was searching for the.
Uh-huh.
Okay, so in this, when we are doing this multiple, so when we are getting, then we have to get some private IP. There we are getting a host name, only one VM is there. Now in a virtual box, we have two VMs. So they must be having their own IP to which we can connect to them. Whenever on a network, there are multiple things and they have their independent IPs.
Okay.
Call it private network to connect to them. So here, what in this Vagrant do, what we are defining.
Mm-hmm.
Okay, so if you see here, this VM1.
Right.
Okay,
Mm-hmm.
VM1 means we have to define here. In this first line, we are configuring the VM.
Mm-hmm.
So when we are using this config word, directly, config VM define Ubuntu VM, we are giving its name as Ubuntu. Suppose we are creating Ubuntu VM, we are creating CentOS VM. We have these two VMs. I am taking an example of two VMs. To differentiate, I am defining it is an Ubuntu and what I have VM1.
Okay.
Okay, so VM1, VM hostname Ubuntu VM. VM1, VM box Ubuntu plus 364. So virtual box. Okay,
Mm-hmm.
and then the network is private network and this is the IP address at which it will have. We will give this IP address to. Okay, so
Okay.
and then here we define the for VM1. For VM1, we are defining a virtual box. Okay, so config VM provider virtual box and then the name is Ubuntu VM. I have given GUI true and VM memory 1024.
Okay.
Okay, and okay, then config VM provision only to see that yes, up it has been created. We have encode hello from Ubuntu. Okay, and then it is an and of this do ends here.
Okay.
This do ends here, and this is a overall do which will end at the end here. Okay.
Okay. Mm-hmm.
Now in this I have configured VM1.
Mm-hmm.
Then I have copy and pasted here again. I have only made a change in the define because I am defining CentOS VM. Okay. Then hostname CentOS VM. CentOS 7 is this. And IP address will be here IP address is 192.168.10. Here IP address is 192.20.
Okay.
Okay. Then what I have done config VM provision virtual box. Okay. And then shell and run command.
Okay.
Okay. Now if I will say here vagrant up. Now if you are seeing here the name bringing machine Ubuntu VM and CentOS VM.
Yeah. Mm-hmm.
So first VM it is provisioning Ubuntu trustee could not be found.
Could not find the provider.
Then it will again box version 0. Yes, we have not added. We have to add virtual box add Ubuntu trustee 64
Okay.
because we have removed we have removed it from in our previous session and previous exercise. We have
Yeah.
removed the Ubuntu trustee 64. That's why it was
Oh, okay.
because this was not present. Therefore, it has given the errors.
Okay.
It has given key errors.
Okay.
Some
Right.
error is there.
What
Other
does the EACCS mean?
this is some error code.
Okay.
This is some error code which it has. The name is correct Ubuntu trust. If you're seeing here, because I tried it out earlier also, so Ubuntu VM and CentOS VM.
Okay.
It is already there with server Ubuntu CentOS VM. So with one, we can create it out. I will just check with the outbox it is importing.
Okay.
It's doing in the background. So what we will do meanwhile, I will show you one thing. Virtual box. So we have this box. So what, like because we have Ubuntu 364 and CentOS S7, both boxes virtual box we have. So vagrant up because I have created new folder so that dot vagrant folder will be getting because it was already there. Maybe due to that it may be giving some error. So let's see. So let's it be done at the back end. Okay.
Okay.
Okay. So what? Let's in the meanwhile let's start with the Git. Today I have to start the Git also. Okay. So I will tell you something about Git version, what is version control and version control system and what is the importance, what is the in need of version control, popular version control system is about this. So there is a certain theory and then we install Git on Windows as well as what are the steps for installing Git, how to install installing on Linux. And then initial setup means how to create a users in a Git when we download the Git. Okay, then creating repository, cloning, checking and committing, fetch, pull and replace, branching. And at the last, there is two practical session,
Mm-hmm.
three practical session which I have created for you. So once we have done, then this practice session, merge branch to master, is for 20 minutes. There are the steps given how to do it, and then how to deploy files to GitHub via Git,
Okay.
and how to uh, another two sessions deploy files. We can use any Bitbucket also. Also, I have given this too.
Okay.
Okay.
Mm-hmm.
Because I have this with Bitbucket. If you want, I can show you with Bitbucket also. Okay.
Okay.
So any this Bitbucket or any other repositories which we are using, Mercurial or a different one, so we can do using this. The steps are same. Okay.
Okay.
Again given an arrow. I will check it out why, because or you can do it why it's not taking Ubuntu test. I have made it change. Okay, let's try with this. There was some issue with Ubuntu Trusty before.
Okay.
Now with HashiCorp Precise 64, it is working.
Mm.
I will check it out later on, and then I will tell you what will be the issue. Why.
Okay.
Now, because the GUI is true, so you have seen that VirtualBox has opened here in a
Yeah.
GUI. If it is false, then it will not open.
Okay.
Because at backend, if you see here, the command is running in the GUI. So now this HashiCorp is there. Hello from Ubuntu, it is coming. If you see here, so this is created. So Ubuntu VM is running. We have earlier web server. Now Ubuntu VM is created, so it is running here in VirtualBox. And CentOS VM starting running. So it has created both the VMs.
Yeah.
Second VM it is created. So in this way we can create a multiple VM in one go. Suppose there is a requirement, a user wants that you have to create a 5 VM. Only in Vagrant 5 you have to define the VMs with the required. Now if here I haven't used this to download and install any software. Otherwise, we can use config.vm.provision, that syntax, and then we can install the softwares by writing it in Vagrant file. So that's in this way Vagrant is being used for this creating a VM. The warning comes here. We have to ignore this warning, connection error, retrieving. It will again try, and then it will. This is a Ubuntu VM running on this. So it will ask if I will close this. It will ask for HashiCorp Precise. Vagrant is a username and Vagrant is a pass. Now it will see login. So we are now on Vagrant at the Ubuntu work. If I say ls, which is only one file, post install. Suppose we have installed some software. So when we do ls, then it will give us that what are the softwares we have used. Okay. Similarly, you can see here CentOS running. So it is showing all the things which it was doing. Okay. CentOS running, it is Linux leaded 64-bit CentOS VM. So when you will go to here, you can see that what is the basic or advanced disabled, what is there. So everything will come here. Okay. System, display, storage, what is the CentOS storage user, okay. Network, host only adapter, adapter 2, airport. Okay, so this way it comes. Now if you see here, this Ubuntu VM, CentOS VM, two VMs has been created. So you can start from here. You can just say start. It will show, it will start running. So in this way, we create multiple VMs on Vagrant. So you will try it out later.
Yeah, I'll try. Mm-hmm.
Okay, so let's start with the Git.
These multiple files, correct?
Yeah, multiple files. So I have shared two Vagrant files. One is Vagrant file and one is Vagrant, then in parentheses 1. So Vagrant file, simple Vagrant file is for creating a single VM and installing a software there. That is the word. Second Vagrant in parentheses 1, that is to create a multiple VM. So I will just give you a task also, create a VM. Okay, so that you can also write how to write in Vagrant file. You just take copy VM1 or VM2 and to make it as VM3. Create 3 VMs. Okay, one is your Ubuntu Rusty 64. Okay, second is equal to HashiCorp with size 64. And third is your CentOS /7. Okay, now in YVM you have to provision Apache 2. Okay, in ZVM you have to provision Tomcat service. Okay, So this is your practical for using Vagrant 5.
Okay.
Okay.
Thank you.
So I hope when you will practice this, then it will give you a more clarity.
Okay.
Okay. So you have to create a 3 VMs Y, X, Z, and in Y you in Z you in X you have not to install anything. In Y and Z you have to install this to vision the software.
Okay.
Okay.
Mm-hmm.
So now we will start with Git. Okay, I was on this website. So in today's session, we will cover all these things: installing on Windows, initial setup, Git initial, creating repository, cloning, check-in, and committing. So now, why we use a version control system? We use a version control system because now, if you see in a let's see a scenario where 5 developers are working. They are developing different 5 modules of an application. They have 5 developers are working. Now, when 5 developers are working, so when they are working on their local, they are saving all their codes and this on server. Before any version control system comes, what they are doing, they are saving on their local. Now,
Okay.
what happened if developer 1 is absent for 4 days? Now, developer 2 has to work it out. So, and the developer 1 has not shared all his codes and files with the developer 2. So, the work will not go forward because the developer 2 is not having any code. He will not start from the scratch because it is on local. They are local and they are just so therefore the need for version control comes. So version control means that when earlier what the developer is doing a version control, but he is saving his file with different names. Suppose he is creating XYZ. The file name is XYZ. So first he has created XYZ and then again he has saved it as XYZ.1, 0.1, then 0.2, XYZ 0. So he is having all this, but it is in his local repository, in local. So therefore, source code to track the modification. Now, when we are using a version control, whenever developers commit to that version control, so version control system, that whatever we have different version control system, they automatically rename it as, and they gave now on the same code, 3 or 4 developers are working. First scenario we have taken 4 or 5 developers are working on different modules, and then they are committing. They are on their local system, and then when they are going and they are giving to at one place and integrating it. But now in one module, 3 developers are working. This is the second scenario. Now when 3 developers are working, so one developer has developed, he has checked in. Other has also developed for the same module, some other task he has done, and then he has checked in. So the file name will be same. So whenever he checked in, then it will take an update version. It will merge it out. It will be in branches, and then the branches will be merged to the main. So these are the 2 different scenarios. One, they are working on they have taken the different branches of a module and they are working on it, and then they are putting it there. And after branch, it is converted into a master, the complete one code. So whenever they commit to the version control system, it takes that the person who has committed the date, time, as well as the version number, because automatically they have not to manually maintain.
Okay.
So therefore, the version control is to track the modification, clock and compare earlier version. That when, at what time it is done and what are the earlier versions. And there is disruption, minimizing disruption. Because even if developer 1 is not working, suppose instead of developer 1 is working, now developer 1 is absent. In his place, developer 3 is working on on that module. So what he will take? He will pull the code from this version control system on his local, and then he will do it and he will commit it. And when he will commit, then his name will come, his time will come. So even developers cannot blame each other that I have not done. This is done by him, I not by me. But because the name, time, and everything comes, so it can be tracked easily for the modification. Is it clear?
Yes, it's clear.
So by the need, files are checked into version control by registered users only. So we will see when we install Git, then we have to register it as a user. Then only we can start doing that. If you are not registered, you are not able to do that.
Okay.
So why this is thing? So it will be that who has committed the code. The username and timestamp of the check-in are associated with the revision. Suppose developer 1 has created a code, he has committed. On Monday at 4 p.m. he has committed. So it will come developer 1, Monday with date and the time that at 4 p.m. it was committed. Now he has he just find now there was some he find that in his code he missed to give some input. So he will then he will make those changes in his local copy, and then he has again committed. Now it is after 1 hour he has committed. So what it comes, developer 1 Monday at 5 p.m. He has committed the code into a version control. So the tracking will be very clear, and the version numbers are there. So each file check-in gets a new version.
Okay.
So suppose the file name is XYZ, developer 1 has done first commit on Monday 4 p.m. So it will be XYZ.1 or version 1. Now at 5 p.m. he has again committed, so it will be developer 1 Monday 5 p.m. XYZ.2. So version number, new version always get the number. Now suppose branching where the head of the repository is split for the parallel development. So we have seen the second scenario where 3 developers are working on one module. Parallel development is done so that it will be fast. So in Git, what we will do, we will make the branches. Suppose we have given a module name that ABC. Now in ABC, we make the branches dev1, dev2, dev3. Developer 1 will commit in dev1, developer 2 will commit in dev2, and developer 3 will commit in dev3. So we make, if this version control system supports a branching, and these systems are organized into repository. So the scenario can be a developer is working on 2 applications. Okay, is working on 2 applications. So when he is working on 2 applications, what he will do? He has given application 1, then application 2. Now he will commit in application 1 and application 2. So application 1 and application 2 are the repositories, different repositories. So in this way, we can source control can be organized into repository. He is working on multiple modules, so multiple applications. So as per his application, he will create a module. So this is the why we need a version control system. Excuse me. Now popular version control systems, we have Git, GitHub, we have SVN, Apache, we have Bazaar, we have Mercurial, we have CVCS, Tortoise. So we have this different version control system. So now if you see Git and GitHub is the most
Git
yeah.
is Git is
Yeah.
the most used.
Yeah.
Okay.
So Git and GitHub is Git is on this, and GitHub is on remote repository.
Okay.
Git can be on your local. GitHub is on remote. That is on this at a location HTTP version. So Git and GitHub is same. Git is your local version control system which you can create on your machine, but GitHub will be on remote. We have Bitbucket also from Atlassian. We have one control system. So these are open source. Bitbucket is not an open source. We have different paid versions also. These Git, GitHub. So if you use GitLab, we have one GitLab also. GitLab is an enterprise version of GitHub. So enterprise version, any enterprise version is a paid version. License is there. From Atlassian, we have Bitbucket. So Bitbucket is a paid version. It's not an open. These are the open source. SVN from Apache, Bazaar, Mercurial from Mercurial, then CVCS, that is Tortoise, and Git. These are open source. These are not paid versions. We have Git and GitHub is not a paid version, but GitLab. If you use a GitLab is an enterprise version and it is a paid version. License is required. So I'll tell you one, when we are working in a DevOps, so we don't start implementing DevOps immediately. We do the assessment. As in my first session, I said we do the assessment. So when we do the assessment and when we interact with the customer, we study their ecosystem, and after studying their ecosystem, and suppose they are using some tools, so using existing tools. Now the customer says, I don't want to use any licensed version. I only want to use an open source. Okay, so in that case, we will recommend the open source. Now a customer is a healthcare customer or a banking customer. So healthcare and banking customer will not be ready to use an open source, because in open source, the security and banking and healthcare, so they are more, so they want a license version. So we provide them the license version. Now, some customers says to us, we need this DevOps on enterprise level. We use tools on enterprise level, but we will not use a license version. Then we have to explain them, because at any enterprise level, when we are doing at enterprise level, we need a enterprise version of that, and all enterprise versions are not open. So if you are using GitLab, GitHub you can use, but when you are using on enterprise level, that is, in that case, we have to recommend it to them. We can to say that, you have to make this in this sprint. This is the requirement you are using. You have wanted us to do it on enterprise level, so we need to be a license version. So in this way, by studying their ecosystem, their requirement, and then we suggest the tool to them. Okay, so these are the open. So the paid version are Bitbucket, GitLab, and more are there. paid version, that is licensing. Now, importance of version control system. On your screen, you are seeing the importance. So, what are the importance? Because with this version control system, we can easily help in tracing the development, that at what level the development has reached. Now, if you see when we are using waterfall or some method, and we are not using a version control system, we cannot see that what is the progress of our project, because developers are working on their locals, and then what they say, we have to think that yes, only 5% done, 10%. But now with version control system, because source codes are committed on a version control system, we will easily, we can view it out from there that what percentage of work has already been done. So it helps in tracing the percentage of work done. Second thing, it helps us now 5 developers are working. So the developers cannot blame each other that no, the maximum part is done by me. The maximum part, you have not done much. I have done all these things. No, because when they will commit to the version control system, their name, the time, and the file name, and their authors all are being there. So it for a project manager or a lead to take to analyze what contribution the developer one has done, what contribution developer two has done, he can easily trace out from this. And recent updates committed the latest version, we can take it out from the version. If there was no version control system, developers are maintaining all these things on their own local, so we are dependent on them. What the copy they have sent, that was the latest version. But with the help of what is the importance of version control system, even the lead or the project manager, if a developer is absent, can take it out from the version control system, the latest version. Because whenever we are using a version control system, it is required for each developer that they have to commit to the version control system on either twice a day. It depends on the organization, or twice a day, thrice a day, or at the end of the day. Before you are leaving the office, you have to commit your code, whatever is developed by you, so that if next day a developer is absent, another person can work. He can take out the recent update, and then he can work on that.
Okay.
And another important thing is, suppose developer 1 has done for 3 days. Now he is absent for 4 days. Next 4 days, developer 2 has done it. So we can also, the lead and the project manager can also track out that what is the contribution of developer 1 and what is the contribution of developer 2. Because when they will commit, their name and timestamp will. Another thing is the truth files will be there at a particular storage location. Next importance is continuous integration is easier. How continuous integration? So because when we have developed a CI/CD pipeline, now as soon as a developer commit a code in a version control system, the CI tool, whatever the CI tool, either we are using Jenkins, we are using Bamboo, we are using TeamCity, or any other CI tool we are using. Because in CI tool, when we create a CI/CD pipeline, we mentioned that as soon as a developer commits a code, it will start a build. It will check. It will do the code quality. So whatever so gated checks are there. So immediately when he commits and CI tool has initiated a build, or CI tool has checked the code or have done a unit testing. So as soon as it is done, the CI tool will call a unit test tool, and then it check it out. Immediately the developers come to know. A notification is going to the developer. Yes, this is the error which you have committed. So in this way, there is an error in your code. So he modify, and then he again checks. So it is now what happening. It is also important because it is a collaborative. Developers has checked in a code. Unit testing is fine. Code quality is fine. It has gone to the tester. Now tester has checked out, has done the functional or whatever testing is done. He finds some error. They get it checked. A notification will go to the developers that there is an error. Now the developer has not to wait till the end of the testing. Immediately he will get it out. He will make the changes, and he will again. So it is a collaborative and remotely task force. Remotely means that a developer is sitting in one office, or he is working from his home. He is working from his home. Tester is working from his home. So it is not that they all are sitting at one location, or they can be sit in a different location of an organization, because it is as soon as it's committed, and when the tester check it out using a tool, and then a notification will be seen. So it is not that they are sitting at the one location with near to each other and then doing it. So it is collaborative as well as remote. Okay, so these are the important. Is it clear or?
Yes, it's very clear.
Okay, thank you. Now, role of version control system in DevOps. So I have given you this. It organized product-related artifacts. Peer reviews are done immediately. Monitoring of documents are done, and there is the collaboration. There is a win-win relationship between dev and ops because as soon as it is checked in and those ops team also gone. So now, in earlier, if you see before the DevOps, developers are blaming operations teams. Developers say no, our thing is correct. Operation has done something, therefore it is not working. At our system, it is working. Why it's not? So because it is a gated checks are there. With each and every step, gated checks are there, so we can come to know where the error is, and it goes back, and then again it will be. So there is a win-win relationship between dev and ops, and even it is a tried and tested result, guaranteed result. Yes, monitoring is being also done. So all these things helps in a version control because whenever you initiate whenever a CI tool initiate a build, so it take out the latest second version. It takes out the latest second version, and then it will the other steps are done, testing and all this. It will done with the latest. So it is that the yes, it has been okay.
Okay.
Sorry. Now types of version control system. We have two types of version: centralized version control system and a distributed version control system. Centralized means that a central server is there, and a version control system is there, and on the central system, all the commits are being done. The developers are doing on their local, and then they are committing to the central server. So that was a central
Okay.
so that central server is being used. It is a client server model. Okay. So earlier it was a client server model. So there was a one server, client server, and the version control system is on that. And from there, or whoever developers are there, person are involved in the product development and maintenance, they are using that central repository, which is on that central server.
Okay.
So what is the problem? We are saying that there was a conflict if two people change the file on the same time. But there are some solutions which can be done by lock, modify, unlock, or copy, modify, merge. So what one person when he has push a request, push means he has taken a code from there. So at that time he do the modification, then he pull it back into this, push it in the version control system. Then he will push into version, then he unlocks. After that, this other person can do it. Second thing is copy, modify. That each person will take out his have pulled it from the version system, make a personal working copy, and then he make the changes, and then he merged it into. When he will push back to the version control system, then he will merge into a that. So in this way it works. But this central repository, the next diagram will show you how the central version control system. If you see in this diagram, three developers are working. They are working on their working copy on their laptop. They update it, they commit it out. When they have to make an update, they pull it out from the repository, working on their copy. From the server, they pull it out, and they are working on their working copy. And then after making it, they are committing this. Now it's okay to working that even we get the latest version, we get everything. But point which we are facing here, in case if the server is down, if a server is down, at that time nobody will be able to work it. They will not get the latest copy, they will not. So that's why distributed version control system. So central version system is a server is down or server has crashed because it is a client server model. So if a server crashed, then it is not possible to work on that. All the work has been lost because the working copy which the developers are having, they have the latest version because they are copying on that working copy. They don't have the previous version. So all old versions will be lost. Therefore, the distribution version control system. So distributed source control system creates replicas of repository on each computer. Each user has to, when they will pull from the repository, so they create a complete replica of that. I have told you repository application 1. It is having different version control. So when they will pull it out, the complete file version will come. The complete directory will come, and it will create a replica. What we say clone. We clone it out. We worked on it, and then we push it back doing the commit. So when they are taking out, they have the complete code, complete replica, whatever is on distributed. Now in the client server, they are taking the latest version only. There is no option to take the clone it out. Okay, so that's why these Git and Bazaar are distributed controls. Now if you see here, this we have a repository. Now they have pulled the repository, developer 1, developer 2, developer 3. They have pulled the complete repository, and from their complete, they have cloned it out, and from there they have checked out the working copy on the on the code file, which code file they need, they checked it out, they worked on it, and then they will commit on the local repository and then push back to the main remote repository. Is it clear?
Yes, it's very clear.
Okay, so in this way, now even if there was any issue in a server, but the developer has the latest clone of the complete repository. Suppose because that is in distributed version control system, it is also stored on a server. Now server crash out. Every work, the work has been lost, but each developer has the clone of that repository on their local, so they can push it back the latest version with all older version also, because they are cloning the repository. Is it okay?
Yeah, it's okay.
So this gives you the features of distributed system. It is based on immutable snapshot of state and tree structure. So in that, the user can work offline also, because he is cloning and then working on it. So he can work on offline also. It is fast and supports a wide variety of workflows. It is easy to use once the standards are set and allows various development models. So this is the features of distributed version control system. It's okay?
Yes, it's okay. Yeah.
So why repositories are the key tools in DevOps? What we have done, if you see in this figure, we have different branches also, tags also. So we can merge into 1, 4, 9 as a main branch, 2, 3 are the branches. So they are making into 3 and then they are converted into a main branch. So in this way, repositories can become very complex. Branches must have integrate relationship. We can branch it out. Branch it out means that when we are developing a module 1 and creating this, and even the branches which are not required can be deleted. If you see in this picture, we have branch 1, 4 and 9. Now the branch 10 is not required. This development branch is not required. So we can delete it out and we can tag it differently, tag 1, tag 2 or trunk. So we can tag this so that it can be easy to extract. So there is a relationship between branch and merges. So what, suppose we have taken a main branch 1, we have created 2 branches 2 and 3. Now the requirement is that we have to merge into a main branch 4. Okay, the person has worked, and when they have, instead of branching to the 1, they have to make it into 4. So once branch 1 is merged into 4, and when main branch 1 is copied into main branch 4, and when the developer 2 and 3 branch has been worked on, developers has worked on branch 2 and 3, then they merge it into 4. So we have all the things of main branch 1 into 4, because we have done copied it into 4, and when it has been modified by in branches 2 and 3, and then it has been merged there. Again it was created and merged into 9. So in this way, it based on the requirement. This is one requirement where it is, or it can be that the figure can also be like that. I will just show you in a figure. We have a branch 1 here. Now this branch 1, two, and then 3. They have worked on it. So now it has been done as this. Okay, 1 and 2.
Mm-hmm.
So once it has done, then it will again merge into branch 1 only. Okay. After making changes, it's again into one only. Okay. So this is also one scene. Or the requirement is that main branch is 1, 2 and 3 are main is 1, 2 and 3 are branches. Once it has been done, then it will merge into one. Is it clear?
Yeah. Mm-hmm.
Okay. Here we have seen that yes, we have 1, 4, 9. We have 3 main branches. Now we have 3 main. Now 2, 3 are branches. Now instead of what they want, that whatever is in 1 and 4. So after when the branches are being done, then they will merge into 4 from 1, 2 and 3 and they merge into 4. And once 4 is being done, then it again branches are created 5, 6, 7, 8 and then 5 and 6 and 7 will be merged to 9. 5 and 8 into 10, but the 10 is not required, so it will be deleted. This branch is not used, 5 and 8 are not used, so it will be deleted. So this way, it depends on the scenarios, the requirement, what is the present requirement of this, how it will be done. Whether if main branch is one only and it is divided into different, main is one and it divided into different branches and then they were merged into the main branch. We have feature branches, we have development branches, we have different this branches and they are merged into main branch. Clear? Or it can be we have different main branches. It will be done. So it will not be done into one, it will be into a new branch. So if you see here, one is the main branch and it is main and it is divided into 2 and 3. When it is done, it is merged into 4. Then again, 4 is divided into 6 and 7. And here, 4 is tagged as feature branch. 9 is tagged as development branch. And then when 4 is done, 6 into 6, 7 and 6, 7 is done into main 9 branch. Main branch 9. So there can be two cases. One is that like this. One is main, divided into 2 and 3 branches. Development is done and it is merged into one. Now Git repository, how Git works. We have this repository git.git v1 v2 and this is a working directory, projects my project. So this is consist of repository and the working directory. Under working directory, because we have created a working directory and with that we have created a repository. So yeah, now 3 stages of Git. We have working directory, staging area, pre-commit holding area and commit. Git repository, that is we have. We have remote repository, that is GitHub, and we have master branch. So if a requirement that it will be have a master branch also. So we have a one master branch and in that and then we merge to the master branch. So we have a working directory, that is we created. Suppose the project name is A, we have created a working directory A. Staging area, pre-commit holding area. That is staging area means before committing, a developer is working on that area. And then he will commit into the Git repository. If you see here, after commit a new branch, master branch, commit 1, commit 2, commit 3, and the new branch. A new branch is created, master and new branch created, and then it will be merged into master. So this is about how to create the branches, and this we will see in the practical also. Now Git terminology. So popular terminology is commit object. We have had hook and index, that is dividing into just like give me 5 minutes. Yeah. So whenever we work in a Git, so we have a working directory, staging area, and repository. What we have seen the 3 stages. So working directory means where we work it out, and we create a directory, we work on it. That and then what is happening between working directory and staging area? We work and git add. We use git add and then working area and to the staging area. Then after committing, it goes to repository. So next figure will show working directory, git add, which have an index. Now here comes what is an index. So git index is a thing where we places a file. Okay, before committing, we places a file, and then you can see a cache or directory where we place the file after adding it, and then we do the git command. First commit, which will be a master. So this is a we can say that in this way we work with the Git. When we install a Git, then we will show you what is a working directory, what is the index, and how we commit. Okay, so this is what if a terminologies. So if a terminologies you see where repository tag or tree, status, add and rebase, merge master, had hook and index, commit or commit object, checkout, branch, push and pull. So these are the popular terminologies. We tomorrow after installing, I will just show you how it works. Okay. So this is working directory, staging area, and repository. Working directory, staging area, repository. So how using working directory when we work on, we add it into an index. Staging area is the index. So we work it out. We add first. We use git add. So git add goes to an index, that is staging area, and from there when we use git commit, then it will go to the master. So this is on. Okay. Thank you. Okay. Bye.
Thanks for watching. Don't forget to subscribe to our channel.